Hi, this is Bill Punch from Michigan State University with another video in a series of videos, The Practice of Computing Using Python, CSE 231. Today we're going to build our first example class, a clock class. Let's go ahead and get started. So we're going to write a series of requirements for our clock class. Each instance of a clock will have associated with it hours, minutes, and seconds, no days. The default value we want to be associated with each one, if we have a constructor with no values, will be 0. We would like to be able to print each instance of a clock. And then the last thing we want to be able to do is add two clock instances together. That means that in the result, no hour will be greater than 23, no minute or second will be greater than 59. And if there's a carry out from hours, we don't represent days, so we don't pay any attention to those. Here's our first version. This is our clock class, and we use a special keyword inside the suite of the clock class called pass. Python does not allow an empty class suite or an empty function suite, so in substitute for that, if we use the word pass, it means on purpose we're putting no extra information in. So this is a class that we've provided no extra information with. Python does all the work. What do we get for that? Let's run the constructor and take a look at the pieces. We do get a constructor even though we've done nothing. We get the default instance this way, and that's what we get. If I print it, I can print the clock class, though it doesn't look very nice. That's what it prints as. Its type is type clock, right? So a clock type was created, and it does have things in it according to the dir function. Most of them are the double underline elements that Python provides by default. So even though we do nothing, we still get a class. But let's try to insert ourselves into this process a little more clearly, and let's build our own constructor. What does the constructor do? It has 4 parameters. The first one, as always, is self, the instance that we're trying to create. That's the default instance coming in. And then hours with a default of 0, minutes with a default of 0, and seconds with a default of 0. And every time we run this, we say, for the default instance, now bound to self, the data attribute hours, I want to set it to the parameter hours. For the default instance, under the data attribute minutes, inside of there, I want to set it to minutes. The default instance, under the default attribute seconds, I want to set it to seconds. So this expression says, for the default instance, I want to create a new data attribute called hours, and I'm going to set it to the parameter hours. And it's clear that hours on the left-hand side refers to a data attribute of an instance, and on the right-hand side it must be the parameter. If I run the same things that I ran before now, we should get some different results. We do. First of all, double underline init does show up. So now we have an initializer. And you'll notice that hours, minutes, and seconds are now part of the instance because when it ran through the initializer, it created a new instance. We can also now use other than default parameters, and we can run printing of the hours, the minutes, and the seconds. Right? And that's what we get. Remember, the init does not have a return value, just like it says. Right? No initializer has a return value because of the pipeline that Python creates for initialization. All right, let's go to version 3. We're going to do clock arithmetic on our initializer. I'm not going to go through the math, but you should be able to follow through. If you get more than 60 seconds, then the carryover should go to minutes. If you get more than 59 minutes, the carryover should go to hours. The hours should never go above 24. Can you follow that math? I hope you can. But if we run it, we make a clock that has 60 seconds, 59 minutes, 23 hours. The extra second should carry over to an extra minute. The extra minute should carry over to an extra hour, and we should get 0 for all 3 values, and we do. So now our initializer runs, and it creates, if we hand in values that are out of range, it does the proper correction, and that will be useful in a minute. Here's our version 4. We keep the initializer that now does clock arithmetic, and we're going to add a print clock method. It takes only self in, and then it prints the hours, colon, the minutes, colon, the seconds, colon. And again, what we do is we say, for that instance, its hours. For the instance that it's called on, its minutes. For the instance that it's called on, those seconds. We also use the formatting element 02D, so these things are too wide, and if it's a single integer digit is preceded by a 0. So if we were to run that now, the clock initialized to 10:55 prints out as 10:05:05. Lastly then, let's look at the add clocks method. Two important things we want to remember about add clocks. It should be the case that we do not modify the existing clocks. That would be weird if their values were changed as a result of the addition. Instead, what we would like to happen is that we are going to return a new clock instance. So the two clocks that we add together will not be changed, but a new clock instance will be created reflecting the addition of the two clock values. Here is our updated version 5, everything we had before plus the add clocks method. Let's take a look at that. Add clocks takes two arguments, self, which it always does, the calling instance, and then a second clock called clock2. We take those two values in as parameters, and then we make the following calculations. We say, look, in the instance that called itself, the value of seconds contained in that attribute plus the values contained in clock2 under seconds. We add those two things together and create seconds. Same for minutes, same for hours. And then when we're done, we take the summed hours, minutes, and seconds, and we call the constructor, the clock constructor. We make a new clock instance using those three sums, and we remember that our clock instances constructor is pretty smart. It does the appropriate clock arithmetic when it makes the new clock, so we don't need to look at the resulting sums, and then we return that new clock. We did not change anything in the calling instances, either self or clock2. We just made a new instance and returned it. So here's our example. If we run this, we'll note that the first clock is 59 seconds, 59 minutes, and 10 hours. We add 1 to each one of those. So 59 and 1 makes 60, so there's a carry. 59 and 1 makes 60, plus the carry is 1. That's a carry. 10 and 1 is 11, plus the carry is 12. Notice that C1 and C2, the original clocks, are unchanged, but a new clock instance is returned, which we can call and look at using the print clock method.